Okay, then here I will introduce some of the direct observation methods of photochemical reactions. As I mentioned earlier at the beginning of the photochemical reaction analysis, as I mentioned, the photochemical reactions too fast to observe directly. But in the last tens of years, researchers have developed several new methods to directly observe the chemical species in time. It is a time-resolved technique. Then, in some cases, you can directly observe reactant product and the intermediate species. And then you can understand the reaction mechanism for each step, which is different from the quantum efficiency measurement. It's a traditional technique. For example, in the triplet, if you have a triplet excited state, right, we analyze this differential equation. But if you could directly observe the concentration of triplet state, we don't have to do that, right? So there are many different optical methods. As you see, that in the optical method, light is illuminated to the sample, and you measure the absorption spectrum. And in some cases, people measure the light emission, fluorescence or phosphorescence. And in a more special case, you may observe the light scattering and thermal or acoustic wave generation. And then in the time resolved technique, so you use a pulse light to induce a chemical reaction, and then measure the response for these to observe the chemical processes directly. So one of them is called a time-resolved fluorescence. So which is you could observe the fluorescence response in time directly, which is the direct information of the singular state lifetime, right? And other method is called a transient absorption measurement, meaning that absorption is monitored for monitoring a chemical reaction, for example, ground state absorption and excited state absorption, and you could see the difference. And there could be some intermediate state absorption. So depending on the absorption change, you could directly see the response of the different chemical species. Okay. So with that, we studied how to analyze chemical processes by using traditionally using the kinetic analysis using steady state approximation, and show some example. And also I introduced some of the up-to-date techniques to directly see the chemical reaction processes.